Sound. Sound is the vibrations that travel through the air or another medium and can be heard when they reach a person's or animal ear. Pass through the eardrum and with the help of three bones, malleus, incus and stapes, under the cochlear muscles, the fluids also vibrate, propagate, and the hair cell is also vibrate according to the vibration in the fluids, and it produces the electrical signals, and these electrical signals goes to the brain. In similar way is produced in the electromagnetic waves, and these electromagnetic waves are generated by changing the dipoles, and based on that these electrical signals transmit from one end to another end, parabolic antenna, and this parabolic antenna is reflect these waves and it catch to the LMB. Look at this is the LMB, and the inside of this LMB is a waveguide, and this is the probe, and this probe is actually sense these electromagnetic signals and it transmit to your set-top box, and the video is displayed. So this electromagnetic waves is converted into electrical signals through the LMB, or it directly catch into the mobile phone. And look at the variations of the electromagnetic waves. And these oscillating dipoles, look at, is produce the electromagnetic waves. So signal is defined as any physical or virtual quantity that varies with time or pace or any other independent variable or variables. So look at, so it is basically a physical or virtual quantity. So physical quantity means the variation of temperature. So temperature is a physical quantity, so its variation with time. So it is also a signal. Signal carries information from one system or network to another. So the physical parameters variation may convert into electrical signals with the help of transducer and transmitted through wire or wirelessly. So the information of the electrical form for transmission with two types of signals, namely the analog and digital signals. The variation of physical or virtual quantity, like the temperature variation with time, color variation in any animated video, that red color variations, white color variations. So these are the virtual quantity. The sound variation, again the another example. Look at. So this is the variation of sound, and it is also a signal. Now we go to the analog signal. Analog signals are those in which voltage and current vary continuously within the specified range. So look at here, the voltage varies continuously and the specified range plus 10 volt to minus 10 volt, and they can take infinite values within the specified range at any particular instant of time. So let we explain this point. They can take infinite values. So you may know that the plus 10 to minus 10, like 5.01, 5.000, 123, 5.0000, 786, etc. So it may take any values among these infinite values. So not means that its value is infinite. Actually, the parameters, the numbers is infinite. So this is the analog signals. So analog signals are continuously and it can take the infinite values. Now the digital signal. A digital signal is that represents the data as a sequence of discrete values. In case of analog, it is continuous, but in case of digital, it is discrete. So a digital signal can only take one values from a finite set of possible values at given time. So this term is important, that it take on one values from the infinite set of possible values. So we can explain this again. So within the digital signals, the physical quantity representing the information can be many things like variables, electric current or voltage. So this is the analog signals. So it is continuously varies with time. So this is the voltage and this is time t. Now these analog signals are sampled or discretized, means this variation of temperature or sound we are not interested to take the all values, because these values are infinite numbers of values, possible values. So we may avoid the complexity. We only interested on the value at these particular time instants. So the signal start just after the tau. So we interested to take its value periodically. Now for this time instance, after 2 tau, 3 tau, 4 tau, so we are interested about that. So these are the discretization of these analog signals. So first we discretize with time, means after 1 second we want to take the value. After 1 second we measure this value, 2 second, 3 second, 4 second, like that, or 0.01 second, 0.02 seconds, 0.03 seconds, means after a certain intervals we want to measure these particular values. So we take the amplitude of this point, a particular time, after time duration we want to take this value, we have to measure this value. Now the variation between 12 and 13 time period, that it is a minimum, and we avoid this because during the sampling discretization these values are not considered. So if we closely take this measurement, means if we sample these signals more fast, then it is possible to observe the variations here or record the variation here. So what are the drawback? The number of samples increase and it will take more memory for operation. So we have to trade off between it. Now these signals is called the discrete signals. After that we have to sample, we have to discretize this amplitude also. So these amplitudes are discretized in a certain levels. Here these levels is 2 to the power n, means 2 to the power 2 means there are 4 levels, 2 to the power 3 means there are 8 levels, 2 to the power 4 means 16 levels, like that. And these are the sampling level, and we called 0 0 0 because there are 8 levels and we have to nomenclature, we have to assign the bits for the particular levels, like 0 0 0 to 1 1 1, because 3 bits are required to assign the number of these levels. So this process is called the quantization process. So in case of this quantization process, the value above this level we assign to the nearest allowable level. So look at, it is 0, so its nearest allowable levels is 0 0 0. For this case it is below this average value, so we have to assign it as 0 0 1. Similarly it is also below this level, so it is assigned 0 0 1. It's above this reference line and below of this reference line, so the allowable levels is 0 1 0. Look at this red line is the actual signal amplitude during the time discretization, and this value is the allowable, and this value is the allowable digitized value. So look at, some value may be overlapped or some may be its nearest value. So look at, for this case it is just above the middle line of these steps, so it should be here. Yes, it should be here. Similarly for this case it is above this line and it is 1 0 1, so it should be here, it should be here because both are overlapped, this should be here, this should be here. So in this way the signals are digitized. So to get the digital signals, we have to quantize this sample value. So first we discretize the analog signal, then quantize, then coding. Quantizations means that we take the nearest value and these nearest values are coded. Here 3-bit coding we used. You may use 4-bit, then this number of steps also increase. You can reduce the duration of this time period. So if you reduce this time period, then you have to take more samples and the signals will more accurate, but the number of operations will increase. So we go back to the definition of digital signal. So a digital signals is a signals that represents data as a sequence of discrete values. A digital signals can only take one value from a finite set of possible values. Here the finite set of possible values 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, like that. So it can take a finite set of possible values at a given time. So with digital signals, the physical quantity representing the informations can maybe many things like the variables of electric current or voltage. So in case of digital electronics, that the signals is represented by discrete bands or levels, but in case of analog signals it is continuous. So this voltage, this signal's voltage is just switch from one level to another level, one level to another levels. That's why sometimes it's called the switching circuit. Also it on and off, high and low. This is also the example of switching circuit. Now this example is taken from the Principle of Communication System, that famous book top selling. Here the signals vary from -4 volt to 4 volt. So the total is 8 volts, and the quantization level, look at the quantization levels we have to determine. Here the number of code is 8. So -3.5, so it is 0 to 4, 0 to -4. So from 0 to 1, 2, 3, 4, 5, 6, 7, these are the code number. And the voltage, we say that 8 volts. So each voltage is 1. And the middle of -3 to -4 is -3.5. This is called the quantization level. So in this case, look at here the value is the sample value is 1.3. So 1.3 is just below the 1.5 5 volt. Okay, so we have to take this is the code number for these signals, because it is just below 1.5, means the nearest line is 1.5, not 0.5, and the 1.5 is coded with 5. So binary representation of 5 is 101. Similarly, for this case it is 3.6, and the nearest quantization level is 3.5, and its binary representation is 7. So it is 111. For this case, look at, for this case its nearest value is 2.5. Okay, so its nearest value 2.5, and 2.5 is represented by 6, so its value is 110. Similar way, for these signals, minus 3.5 is near is minus 3.4, so the nearest value is minus 3.5 and is represented by 0, and so its code is 000. So how we represent these signals? So the one first is 101, 111, 110. So we have to write here 101, 111. So look at this range, we represent the watt time slot, and these are the empty, because we give some pace. So this is the 1 watt time, this is the another watt time, this is the another watt times, and when it is 1 we give the pulse high, 0 means low, 1 means high, so it represents 101. Similarly, it represents 1 1 1, it represents 1 1 0, is represent 1 0 0, gap. Look at, this is 0 1 1, this is 0 0 1. Look at, this is the gap, and it is 0 0 0. So in this way we can represent, and this is called the pulse representation of the binary number used to code the sample. We may represent by voltage level. So 0 plus V to minus V, and this is the reference line. So it is 1 0 1, gap 1 1 1, it is 1 1 0, 1 0 0, gap 1 1 0 0 1 0 0 0 0. So in this way the digital signals is converted from the analog signals. In nature, all signals are analog signals. We have to convert it into digital signals for further process, and from these digital signals again we have to convert into analog signals. Thank you.